The LS1 aluminum V8 is a high-performance engine, providing exhilarating driving for the customer and designed-in serviceability for the technician. In this Certified Plus training presentation and the accompanying reference booklet, you'll see the important engine mechanical service highlights for the LS1 V8. The new small block V8 engine is RPO code LS1 and features an aluminum block and heads. It displaces 5,665 cubic centimeters or 5.7 liters. The firing order is 18726543. The bore and stroke are 99 and 92 millimeters or 3.90 and 3.62 inches respectively. Power ratings for the applications are found in the reference booklet for this course. Before we look at engine disassembly, let's take a closer look at the LS1 V8 engine. One of the first things you will notice about this engine is the coil near plug ignition system. It uses individual ignition coils and short spark plug wires to deliver more spark energy to the spark plugs. The lightweight composite intake manifold reduces heat transfer to the intake charge. The manifold positions the port fuel injectors to target the intake valves for more complete atomization of the fuel. The tall intake ports in the cylinder heads enhance injector targeting. Here is the actual port and flow path to the intake valve. The aluminum cylinder heads use replicated intake and exhaust ports. This means that each intake port is the same as the other 7, and likewise with the exhaust ports. Combustion variation between cylinders is minimized by this port configuration. The valve angles are set at 15 degrees to form a shallow combustion chamber. The valve head diameters are 50.80 millimeters, or 2 inches for the intakes, and 39.40 millimeters, or 1.55 inches for the exhausts. The valve springs are conical, or beehive in shape, allowing for a lighter spring retainer. The roller rockers are made of investment cast steel with a 1.7 rocker ratio used to actuate the valves. Moving on to the engine's lower end, here we see the aluminum deep skirt block. It incorporates cast iron sleeves that are cast into the block during production. In addition, the block uses enclosed lifter bores under each cylinder head. This design provides a stiffer structure and quieter operation over an open valley design. Cylinder heads are attached to the block using 4 head bolts per cylinder. The thread bosses are located deep in the cylinder block to minimize cylinder distortion at the top of the bore, maximizing ring seal. The rigid deep skirt block utilizes cross-bolted main bearing caps. Each main cap is retained by 6 bolts. The thrust bearing is located at the number 3 location to reduce the expansion differences between the cast iron crankshaft and the aluminum block. You'll also notice holes through each of the bulkheads. These holes improve crankcase ventilation at high RPM. The crankshaft is cast from nodular iron with journal diameters of 65 millimeters or 2.56 inches for the mains and 53.33 millimeters or 2.1 inches for the rods. Each journal incorporates rolled fillets for increased strength. Center drilling through main journals number 2, 3, 4, and 5 decreases weight and improves crankcase ventilation at high RPM. A reluctor wheel for the ignition system is pressed onto the rear of the crankshaft. The LS1 uses strong, lightweight cast aluminum pistons with low tension rings and forged powder metal connecting rods. The connecting rod cap is separated during the manufacturing process using the fracture method. Connecting rod center-to-center length is 154.90 millimeters or 6.098 inches. The roller camshaft features large journals that measure 55 millimeters or 2.16 inches. The cam lobes have a large base circle relative to the lobe lift, which helps to reduce valve train loading. The hydraulic roller lifters are retained with unique glass-reinforced nylon guides. Now, on to the lubrication system. A crankshaft-driven gerotor oil pump provides oil pressure to the full-flow lubrication system. A large pickup tube delivers unrestricted oil to the pump under all conditions. Oil is supplied to the main and camshaft bearings simultaneously through a parallel priority feed arrangement. And lastly, we'll look at the engine's cooling system. Coolant follows the conventional flow path, passing through the block first, then the cylinder heads, and finally through the outlet to the radiator. Positioning the thermostat on the inlet side helps eliminate thermocycling. A coolant vapor port, located at each corner of the cylinder heads, eliminates vapor pockets for enhanced cooling efficiency. Additional information about the features of the LS1 engine can be found in the CPT booklet that accompanies this video presentation. In this segment of the presentation, LS1 disassembly is examined. We will only concentrate on what's new compared to the other engines you've experienced. Before beginning, it's important to note that when disassembling the engine, internal components must be separated, marked, or organized in a way to ensure reinstallation to their original location and position. This is because the components will develop specific wear patterns on their friction surfaces. Be sure to separate, mark, or organize the following items: pistons and their piston pins, pistons to their specific cylinder bores, piston rings to the pistons, connecting rods to the crankshaft journals, connecting rods to the bearing caps, crankshaft main and connecting rod bearings, camshaft and valve lifters, guides, push rods, pivot supports, and rocker arms, valves to valve guides, valve springs and shims to their cylinder head locations, engine block main bearing cap locations and directions, as well as oil pump drive and driven gears. The composite intake manifold is designed for operational efficiency and simplified service, as no coolant flows through it. Removal is straightforward. The captured gasket O-rings are designed for easy replacement. Whenever manifold service is required, the gasket O-ring should be replaced. When servicing the coil near plug ignition system, do not remove the spark plug wires from the coils unless coil service is necessary. Ignition coils are serviced individually and are interchangeable. Captured gasket technology also makes valve cover service quick and easy. The rocker arms for each bank of cylinders are mounted on pivot supports and are attached by individual bolts. Before cylinder head removal, the coolant vapor pipe must be unbolted. When you remove the head bolts, use a circular pattern starting from the outside working toward the center. The larger head bolts are torque to yield or stretch bolts and cannot be reused. The roller lifters require cylinder head removal for service. However, the lifter guides make removal and installation of the lifters a snap. Knock sensor service is accomplished by removing the intake manifold to gain access. However, with the knock sensors being located in a dry hole, no coolant needs to be drained. The valley cover and single-piece gasket seal the top of the engine. The cover also provides structural integrity for the block. To remove the harmonic balancer from the engine must be kept from turning. Bolt J42386 to the starter pad, making sure that the tool is properly engaged into the flywheel teeth. Note that there is no keyway to index the harmonic balancer on the LS1 engine. On Camaro and Firebird, the balancer can be installed in any position. However, on Corvette engines, the crankshaft and balancer should be marked prior to removal to maintain proper alignment of the additional balance weights on this application. If replacement of the balancer on Corvette is necessary, new identical dynamic balance pins must be installed in the same locations. To remove the balancer on either engine, first install J41816-2 into the crankshaft. Then position the J41816 jaws behind the balancer. Using the tools, remove the balancer from the crankshaft. After removing the water pump pulley, the water pump and thermostat housing assembly can be removed from the front of the engine. After draining the oil and removing the oil filter, the oil pan can be removed from the engine. The Corvette pan features a unique design to provide additional oil reserve under performance conditions. The pan gasket is a single plane design to reduce the possibility of oil leaks. The original pan gasket is secured to the oil pan with rivets. Once removed, there is no need to re-rivet the replacement gasket. Whenever oil pan service is performed, remove the oil pan baffle and inspect the sump for debris. Clean as necessary and reinstall the baffle. During service, the oil level sensor can be reinstalled as is, providing the sealing ring is not nicked or torn. While removal of the front and rear timing covers is straightforward, installation requires attention to detail and is highlighted later in this presentation. After removing the nut holding the pickup to the main stud, remove the pickup to oil pump bolt. Then remove the pickup. Always replace the oil pump pickup O-ring when servicing the pump or pickup. The crank-driven oil pump is removed easily. At this point, disassembly concentrates on the heart of the engine, the short block. The LS1 uses cap screw bolts to secure the caps to the rods. Once the rod cap is removed, install the J41556 guide to the connecting rod. Use a hammer and tap lightly on J41556 until the piston rings clear the block deck. At this point, you can remove the piston and rod from the block. Pistons can be removed from the rods if necessary by pressing out the piston pins. Before removal of the camshaft position sensor must be removed to avoid damage. The LS1 timing chain is a single roller type. The retainer positions the camshaft exactly in the block. Fore and aft movement is eliminated, keeping the camshaft and position sensor aligned. To remove the camshaft from the engine block, use 3 long 8 mm by 1.25 thread pitch bolts threaded into the timing gear mounting holes. Carefully remove the cam without nicking the cam bearings with the lobes of the cam. If lower timing gear service is required, install remover J41558, pilot J41816-2, and puller J8433-1 onto the crankshaft gear and remove it as you would for any other press-fit gear. The side or cross bolts have an oil sealing surface built into the head. They must be replaced whenever removed. After removing the 8 mm cross bolts and the 10 mm main cap bolts from the main caps, install slide hammer J6125-1B along with remover J41818. The slide hammer pulls straight up on the main cap without it cocking in the block. Carefully lift the crankshaft straight up until it clears the block. However, when setting it on the bench, be very careful that it does not rest on the reluctor wheel. The ignition system reluctor wheel is pressed onto the rear of the crankshaft. If the wheel sustains any damage, replace the crankshaft. If the reluctor wheel is suspect, check the lateral runout. Position the indicator tip 1 mm below the ring teeth. If the runout is in excess of 0.25 mm, the crankshaft must be replaced. The crankshaft oil gallery plug behind the pilot bearing must be checked for oil leakage. All screw-in plugs should be removed from the block before it is cleaned. The cup plug in the main oil gallery at the front of the block should not be disturbed unless necessary. The rear main gallery plug assembly can be removed using a small screwdriver. If the O-ring on the rear plug is not damaged, it can be reused. The remainder of this presentation focuses on engine assembly. Again, we will only concentrate on the items unique to the LS1. When installing replacement components, always check for proper clearances using the procedures outlined in the service information. In the prepped bare block, begin by installing the oil gallery and coolant plugs using GM part number 123460004 sealer. If the front oil gallery plug was removed, a new one must be installed. Install the main bearings in the block and main caps. The grooved bearing shells go into the block. If installing a new crankshaft and/or bearings, be sure to plastigauge clearances to ensure proper fit. After lubricating the bearing shells, install the crankshaft. Install the main caps, noting correct direction and order. Use a hammer and tap lightly on the caps. Then snug all 6 bolts for each main cap. Loosen the center number 3 thrust main cap. Use a screwdriver to set the thrust bearing. Tighten the inner main cap bolts in the order shown in the service information to the torque specification. Then tighten the bolts in order to the recommended torque angle. Similarly, tighten the outer main cap bolts in order to the recommended torque. Then tighten to the recommended torque angle. Tighten each pair of new cross bolts to specification. Before installing, the crank sensor seal must be lubricated. Install the rings on the pistons, staggering the gaps per the service information. Install the rod bearings onto the rods and caps. Install J41556 into each connecting rod. When installing a piston, note that the mark goes to the front of the engine. Also note that all the connecting rods are installed in the same direction. The flat area on the bolt flange faces the front of the engine block. Install the pistons into the block using J41556 to guide the rods to the journals. Install the rod cap to the rod, noting the flat side versus the rounded side of the rod. Again, if installing a new crankshaft, connecting rods and/or bearings, be sure to check assembly clearances. Tighten the connecting rod bolts to initial torque. Finish by tightening to the torque angle specification. After each piston is installed, check your work by rotating the engine 1 turn. Also, move the rod back and forth on the journal. Make sure it moves freely. After all the pistons are installed into the block, check rod side clearance on all journals per the service information specification. Lubricate the camshaft lobes and journals with engine oil and install the cam with the same long bolts used for removal. Install the cam retainer plate with the gasket side to the block. Tighten the bolts to specification. After lubricating the O-ring on the camshaft position sensor, install the sensor and tighten the retaining bolt to specification. If removed, install the lower crank gear key and gear with J41665 until seated to the crankshaft flange. Install the timing chain and gear to the cam. Make sure that the timing marks line up correctly before tightening the timing gear bolts. Make sure that the oil pump is not installed dry. Install the oil pump to the block, aligning the splines so the pump contacts the face of the block. Install the oil pump bolts and tighten them to specification. Install the oil deflector to the main studs. Install the nuts finger tight. Before positioning the oil pump pickup, lubricate a new O-ring and make sure that the pickup is fully seated into the pump. Then, tighten the oil pump pickup bolt, followed by the nuts fastening the pickup and the deflector. Make sure all are tightened to specifications. Front and rear cover installation are two of the most critical procedures on this engine. In each case, the oil seal must be centered to the crank when installed. Also, the cover-to-block sealing surfaces for the oil pan must be dimensionally correct. To begin, install the front cover, gasket, and bolts to the engine. Note that the front cover can be installed with or without the front seal. Only tighten the bolts finger tight. Then install the J41-480 alignment tool to the cover and bottom of the block. Tighten tool bolts to the block to 25 Newton meters. However, leave tool to cover bolts loose at this time. Install the J41-476 alignment tool with the balancer bolt finger tight. Then, with the cover centered, tighten the J41-480 tool to front cover bolts to specification. Finally, tighten the front cover bolts to specification and remove the tools. Before continuing, measure the front cover-to-block oil pan sealing surface for flatness. The cover must be flush or no more than a 0.5 millimeter gap. If it's not, try the alignment again. If the specification still can't be met, replace the front cover. If necessary, use the J41-478 installer and threaded rod to position a new front oil seal. The outside diameter of the seal should be lubricated with engine oil and the sealing surface should be left dry. Use one wrench to hold the rod and another to move the front seal installer to press the seal into the cover. Before installing the rear engine cover, if removed, reinstall the rear oil gallery plug. Rear cover installation directly parallels front cover installation. However, the rear cover must be installed without the seal. Again, the cover gasket and bolts are installed finger tight at first. As you did before, secure J41-480 to the block first and then loosely to the cover. When installing J41-476, make sure to use crankshaft bolt holes that are parallel with the oil pan rail. After aligning the rear cover and tightening the bolts, the cover-to-block oil pan sealing surface flatness must be verified with a straight edge and feeler gauge. The rear cover must be flush or no more than a 0.5 millimeter gap. A new rear oil seal must also be installed. Again, lubricate the outside diameter of the crankshaft seal, but leave the sealing surface dry. J41-479 uses a cone to expand the lip of the seal. The tool's threaded rod installs the seal into the rear cover. For the oil pan, GM part number 123460004 sealant is applied according to the service information. The new gasket must be correctly oriented to ensure the oil gallery passages align. Then the oil pan can be installed. Check oil pan position by measuring the mating of the rear of the pan and the rear of the block. The match must be flush or no more than a 0.5 millimeter gap. The rear of the pan must never protrude beyond the block. Before cylinder head installation, be sure to install the valve lifters and lifter guides. Tighten the shouldered retaining bolts to specification. With the block deck and cylinder head bolt holes cleaned and prepped, ensure the head locating dowels protrude from the block deck by 6 millimeters. With the locator tab closer to the front of the engine and the marked side of the gasket up, position the gasket on the block. No sealant should be used. Position the head over the locating dowels. Then install new M11 head bolts. The old bolts in these locations should not be reused. However, the shorter M8 head bolts used along the upper edge can be reused. Apply an approved thread locking compound. Tighten the M11 bolts in the order shown in the service information to the torque specification. Then tighten the bolts in order to the recommended torque angle, followed by an additional tightening to a specified number of degrees as well. The upper M8 bolts are tightened to a specified torque only. Install the flywheel and bolt J42386 to the starter pad, making sure that the tool is properly engaged into the flywheel teeth. Install the harmonic balancer using tool J41665. On the Corvette, be sure to align the marks on the crankshaft and balancer. After tightening the old balancer bolt to the recommended torque for proper seating, remove the old bolt and check the balancer for proper positioning. Then install the new balancer bolt and tighten it to specification. Tighten it the additional specified number of degrees as well. After lubricating all valve train components according to the service information, install the rocker pivot support, push rods, and rocker arms along with the attaching bolts. Do not tighten the bolts at this time. First, rotate the engine to top dead center for the number 1 cylinder. Slowly tighten the specified rockers according to the service information. Then rotate the engine and slowly tighten the remaining rockers in order according to the service information. Before installing the valve covers, make sure to use new gaskets. The oil fill goes to the right front of the engine. Tighten the bolts to specification. Always use new seals and a new gasket when servicing the valley cover. After lubricating the new knock sensor seal surfaces with engine oil, install the gasket and valley cover. Tighten the bolts to specification. When installing the knock sensors, tighten them to specification. Before installing the wiring harness for the knock sensors, install new gaskets onto the vapor vent tube. Install the vapor vent tube with the bolts tightened to specification. At this point, the knock sensor harness can be installed. Make sure to install the seals completely and secure the harness to the coolant vapor vent pipe. Then install the water pump. At the intake manifold, be sure to use new gasket O-rings. The intake manifold bolts receive a new 5mm band of thread lock per service information specification. Be sure to position the fuel rail stop bracket onto the manifold. This bracket is a critical protection component for the fuel system. Tighten the manifold bolts in the specified sequence to specification. The remaining LS1 engine assembly procedures parallel other engines. Be sure to use the service information for tightening sequences and specifications, as well as engine setup and testing. Thoroughly review the reference booklet that accompanies this presentation. In the booklet, you'll find additional coverage of engine features, overhaul specifications, and the test you must take to receive credit for this CPT course. The aluminum Gen 3 V8 is a high-performance engine. Customers, as always, depend on their trusted GM service technicians to ensure that when repair is required, they know it'll be done right the first time, on time, every time.